what if we need to graph a tangent function that takes the form of a tangent omega x? So for example, let's graph 2 tangent 1/4 x. Well, I always want to start the graph of tangent with my asymptotes. So I know that when the angle is 0, when x is 0, tangent is going to be 0. Because no matter what the omega is, if my angle x is 0, I'm going to have tan of 0. And when I'm thinking about my unit circle, right here at angle 0, my cosine is 1, my sine is 0, so sine over cosine is 0 over 1 is 0. So tan at 0 is always going to be 0. So what I'm going to do is I'm going to draw in some asymptotes, but I'm not going to label them yet. I don't know what points they are, but I know that they're going to be evenly spaced because the period of tangent it's a periodic function. It repeats itself on regular basis. If this was the graph of tangent without any omega and without any a, I know that these would be pi over 2 points. I'm not exactly sure what they are right now. But I do know that I can space them out like this, and I do know that this 0, right there at 0, is going to be exactly between 2 asymptotes. Because the zeros in the tangent function are always exactly between 2 asymptotes. As long as there's not a k, but you can ignore that for right now. Well, the period of this function here that I'm trying to do, I can define the period of a tangent function by going period is equal to pi over omega. Now, I know when we were doing sine and cosine, it was 2 pi over omega. But that's because the period of sine and cosine is 2 pi. But the period of tangent is only pi. So I am impacting my period by omega, and my period of the tangent function is pi. So this is equal to pi divided by 1/4, which is equal to 4 pi. So I've now determined that my period is 4 pi. And just like when I was doing transformations, I would have a times f of b x minus h plus k. The b was inside my function, and I would be multiplying all of my x values by 1 over b. Well, in trigonometric functions, instead of calling it b, we call it omega. So I'm multiplying all of my x values by 1 over omega. Well, in this graph right here, my asymptotes are defined by their value on the x-axis. So if this was a parent function, this would be pi over 2. It would be x equals pi over 2. That would be my asymptote. So all I want to find right now is I want to find one asymptote of this tangent function that we're working with right here. And I can see that I have multiplied my period by 4. I have not multiplied it by 4 pi, and my period was initially pi. I've multiplied my period by 4 by 1 over omega. Just like I was doing before, 1 over b, it's 1 over omega. So I'm multiplying all of my x values by 1 over omega. I'm multiplying all of my x values by 1 over 4. And my asymptote right here is an x value. So if I go ahead and I multiply pi over 2, and I'm going to move that by a value of 4, that's my 1 over b, I get 2 pi. So instead of it being pi over 2 where my asymptote is going to be, the asymptote is really going to be at 2 pi. So let's erase this. And let's label this point right here 2 pi. Now my period I've determined is 4 pi. So between asymptotes, it's going to repeat itself every asymptote. I have 4 pi, so that means this right here is 6 pi. And that means this over here is negative 2 pi, because between negative 2 pi and positive 2 pi is 4 pi. And this is negative 6 pi. So now I've identified all of my asymptotes. I'm going to follow the same procedure that I followed when I was doing my graph of tangent. Between the asymptotes, right in between the asymptotes, I have a 0. And what do you know? My 0 point is right between the 2 asymptotes. Not a big surprise. Here's another 0. So now I've identified my zeros, and I've identified my asymptotes. The last thing I need to find are my 45-degree points. My 45-degree points are going to come right in the middle between the zeros and the right asymptote and the 0 and the left asymptote. So my 45-degree points are going to happen here, and they're going to happen here. They're going to happen here and here. They're going to happen here and here. Those are going to be my 45-degree points. Well, in the graph of tangent x, my 45-degree points, my y value was 1. But now I have a function that has an a, and that a is 2. It's outside the function. That multiplies times my y values. So instead of my point being at 1, it's going to be at 2 on the right side of this 0, and it's going to be at negative 2 on the left side of that 0. It's going to be a positive 2 on the right side and negative 2 on the left side. It's going to be a positive 2 on the right side and negative 2 on the left side. So I've got all my points, I've got my asymptotes, I've got my zeros. There are 3 cycles right there of the tangent function. And I can label those intermediary points. I know if I have, this is 0 right here, and this is 2 pi, that means that this right here is pi. And that means this must be 3 pi, and this must be 4 pi, and this must be 5 pi. So it's not too tough to label enough points so I can get a sense that you know exactly how to graph this function. And so that's it. That's how you graph a function that takes this form, a tangent omega x. No h's, no k's, but we do have the a and the omega.